Hello and welcome to another ramble. We are rambling today about IEB's paper 2 from May 2025, question 6, which is some trig graphs. Right, so we are given f of x is equal to sine x minus 30 and g of x is equal to cos 2x. Right, so if we think about this in relation to a normal sine graph, so just a y is equal to sine x, this would be a sine graph that has been shifted 30 units to the right. Okay, so if, for example, this is our y is equal to sine x, then y is equal to sine x minus 30 would be something that is sorcery, right? 30 units to the right. So where this one would cross at the origin, this one will intercept at 30 degrees, and where this one's next x-intercept is 180, this one will be 30 units later, so 210 degrees, and so on and so on. Right, so that's the one thing. And then the other graph is y is equal to cos 2x. So again, if we think about quote unquote a normal cos graph, i.e. y is equal to cos x, what does y is equal to cos 2x look like? So this would be one where the period of the graph is no longer 360 but 360 divided by 2. So it's a bit of a squished cos graph. So where we see this would take 360 degrees to complete a wave, so this is 0 and it ends at 360 and then another wave starts. For this one it would take 180 degrees for a wave to complete. So this is where 180 is, for example. So by the time this one completes one wave, the other one will have completed 2. Okay, so this would be the first wave from 0 to 180, and then the next wave would be from 180 to 360, and so on and so on. So this is what these two look like in relation to each other. Okay, right, some nice art. Okay, so the first question says solve f of x is equal to g of x where x is between negative 180 and 90, and including both of those. Okay, so we're trying to find the points of intersection between this guy and this guy. So we are solving sine x minus 30 is equal to cos 2x. There's a couple of ways we can go about this. So because these angles are not the same, that for me kind of hints that I need both sides to just have the same ratio. So for example, if both of them, if this had been cos 2x and sine 2x, then for example we would have been able to divide both sides by cos 2x, turn this into a tan equation and solve it that way. Alas, or if for example, I don't know what's another example, or like if for example this was a cos 2x and this was just a sine x, then maybe I would have been able to rewrite this as 1 minus 2 sine squared x, and kind of so using the double angle identity and then do a quadratic equation that way. So that's what I mean by by looking at this and seeing that these angles are not the same. That's kind of hinting to me that maybe the easiest thing to do is to just rewrite one of these, so either convert this to a sine or convert this to a cos. There is the option of seeing where it might take us to say sine x cos 30 minus cos x sine 30 is equal to cos 2x. There is that option. This would just be a number, so this would be root 3 over 2, and this would be a half. So that would be root 3 over 2 sine x minus half cos x. And then that kind of suggests to me that this side I would need to rewrite. Remember, we have three options for our cos double angle identity. It's either the one that has cos and sine, or the one that just has cos, or the one that just has sine. And because we have sine and cos on this side, I would be hoping that maybe this might take me somewhere. It doesn't look like it's going to. If I move everything over to one side, I'll have positive sine squared x plus root 3 over 2 sine x minus cos squared x minus a half cos x is equal to 0. And then grouping would be the next thing to do. So if I take out a common factor here, I'm going to be left with, so the common factor would be sine x, and then my bracket will be sine x plus root 3 over 2. The common factor here would be cos x, and then in the bracket I won't be left with anything to do with sine. So this is just a dead end. Dead end, dead end, dead end, dead end. So we go back to original idea. So I'm going to use the idea that cos of theta can also be written as sine of 90 minus theta. Right? Remember, sine and cos are co-ratios, so this is a nifty way that we can move between the two. So let us do that. So in this case, we've got cos of 2x, which I can rewrite as sine of 90 minus 2x. All right, is equal to this. Okay, good. And now remember, because of the interesting ways of trigonometry, if sine A is equal to sine B, the one possibility is that A is equal to B, right? But it could also be B plus or minus as many revolutions as we want, right? Because those angles, if you look at them on the Cartesian plane, would be in the same position. So it makes sense that their sine ratios would be the same. But then if we also think about cast, we know that A could also be equal to 180 minus B plus K360 as well, right? And so those would be the two possibilities here. So either x minus 30 is going to be equal to 90 minus 2x plus K360, or x minus 30 is going to be equal to 180 degrees minus 90 minus 2x, and even with that angle we could add as many revolutions as we want to, or subtract as many revolutions as we want to. So those would be our two solutions. So let's get all our x's on one side. So I'm going to add 2x here, and then also get rid of the numbers on the one side, move them to the other side. Okay, so that would be 3x is equal to 120 plus K360. Okay, this guy I'm going to, oh dear, we've got things lined up. I am going to move this to the next page. We'll deal with you shortly, my friend. Right, and then we divide all the way through by 3. So x would be equal to 40 plus K120, where K is some integer. So that would be the one solution. And then, okay, this one we just need to tidy up a bit. So this is 180 minus 90 plus 2x plus K360. and on the left we have our x minus 30 waiting patiently, and then again can minus 2x, right, and then over here we would plus 30, right. So on the left we end up with negative x, and on the right we end up with 180 minus 90, which is 90, plus 30, which is 120, plus k 360, and then we divide by negative 1, okay, and we end up with x is equal to negative 120. And remember that, so the plus, I mean, it doesn't really matter whether you change the plus to a minus or whatever, because remember k can be any integer, so dividing by negative doesn't really change the value of this guy, because if he was negative 1 times 360, he'll just become 1 times 360, and if he was 1 times 360, he'll become negative 1 times 360. So dividing by negative 1 does not change this term at all. Right, so these are then our two general solutions. Now the important thing to remember here is that we're not looking for general solutions, we are looking for solutions in a specific interval. So let's remind ourselves what that interval is. So I'm done with my art project here. So we are looking specifically for solutions between negative 180 and 90, both inclusive. So let's start with this guy. I'm just going to generate them here, and then I'll put them in one place when I'm done. Oh, I don't have my calculator out. Yo, okay. I momentarily thought about doing it in my head, but it's not that kind of day for me, honestly. It's not. So we can start with just 40, so we're not adding a 120 or anything. That works. And then if we minus a single 120, we get negative 80. Wait, what's our lower bound again? Our lower bound is negative 180. Okay, and then we can minus minus 120 again, we get minus 200, so that's too far down, right? So then come back to 40, let's add 120, and that's 160, which is too high. Oh my gosh. So yeah, the upper bound is 90. So we are done with this solution. It has given us all the solutions in the interval that we can find. So we move on to the next one. Here we have negative 120, which is within the interval that we want. So the interval was negative 180 to 90. If I try to minus a revolution, so negative 120 minus 360, that is way too low, so that doesn't work. And if I try to add a revolution, that is going to go to 240, which is too high. Remember, our upper bound is 90, lower bound is minus 180. So this is also all that this solution can give to us. And so this would be the final solution, right? That therefore x could be one of these three things. You could also write this as x is 40, or x is negative 80, or x is negative 120. That's also a perfectly valid way to write out the solutions. Right, next up, we are asked to sketch the graphs of f and g on the axes below. Clearly label the endpoints and the y-intercepts. Okay, so yeah, you could think about, in fact, that's what I'm going to do. I'm going to start by drawing the sign y is equal to sine x, right? That's going to be my starting point. So I know that its x-intercepts are at 0, 180, minus 180, and so on. and it would peak at negative 90 and 1, and it would hit a low at 90. Oh no, what am I saying? Oh, the lies. It is actually, it peaks over here. Oh guys, no die shapes. And then over here it would go over there. Yeah. So it actually looks something like this. Let's try that again. It looks something like that, right? So now we want the graph of y is equal to sine x minus 30, which would be, as discussed, everything is delayed by 30 units. So this x-intercept would happen here now. This little dip would happen 30 units later at negative 60. This x-intercept would now move to 30, and then this guy would move out of view to 120. So it's gonna go some. Oh, I'm not drawing a line, you clever little thing. Oh, I don't know what the y-intercept is. Oh, maybe I should have worked that out first. Okay, so the y-intercept would occur when x is 0, right? So that is sine of negative 30, which is the same as negative sine 30, no die reductions, which is the same as negative a half. So the y-intercept would be somewhere here. And while we're at it, maybe let's work out our endpoints. So, oh, there is so much going on here. I'll just move that here for now. So the endpoints, the one endpoint occurs when x is equal to minus 180. So I'll substitute that in. Sine of minus 180 minus 30 is the same as sine of negative 210, which is the same as negative sine of 210, which is the same as negative. You don't have to do this manually. You really could just do this on your calculator, but it's a very good excuse to practice your reductions. So there's that, right? And we know that sine of 180 plus something is the same as negative sine of the something. So this would be the same as positive sine 30, which is a half. So our one endpoint would be there by negative 180 and a half. And then for the other endpoint, which occurs when x is 90, let's work that out. So the y coordinate there would be sine of 90 minus 30, which is sine of 60, and from our knowledge of special angles, this is root 3 over 2. So root 3 over 2 is somewhere just below 1. I think it's 0.8 something something. Let's just double check that. Root 3 divided by 2. Yeah. Good. Okay, so now I can draw my curve with a bit more confidence. So we have that. Hey, what is going on here? Okay, so this is going to be like that. We curve and then we start going up towards another curve that way. Oh, my y-intercept. Oh, guys, drawing a curve on these technologies is actually not to be taken for granted. Something like that, you know, something better than that, honestly. Like, do better, girl, do better. Right, so I can take away my guiding thing now, and I'm just going to hide my, not hide them, but shrink these calculations. Okay, good. Right, so then for the next graph, again I'm going to start by drawing the graph of y is equal to cos x, and that one we know has a point here at 0 and 1. This point does not want to point you. And then it crosses the x-axis at 90, and mirror over there as well, and then it dips again at minus 180. So it looks something like this. It actually doesn't really matter. I don't really need to draw the curve, but for the sake of you. Right, so then I must do this another color. So y is equal to cos 2x means that for every point I'm going to divide the x by 2. So this one will remain as is, and then this one over here is going to shrink back to 45, right? 45 and 0. And then this one, looking at the wrong graph. And then this point is going to also shrink back to minus 45, and then this one is going to go to minus 90. Okay, so that gives me some of my graph. I need to work out the rest. Okay. So maybe then it would be useful to so let's just see, how much of a curve do we have here? We've got a quarter, another quarter, and another quarter. So this needs to complete, right? And each quarter we can see takes about 45 degrees, right? From here to here is 45 degrees, from here to here is 45 degrees, from here to here is another 45 degrees. So I'm going to have another x-intercept at minus 135, and then I'm going to have the next eventful thing happen at minus 180. That's going to be my next peak. And then likewise on the right hand side, my curve is going to hit a low at 90. Right, so these things can also just be done on your calculator. Like, you can just, I think there's a fancy way where you can generate points for your function on your calculator or something like that, and then draw it that way. Whatever works for you at the end of the day, whatever gets you those marks. All we care about is marks. Unfortunately. Okay, right, so we are asked to label endpoints and y-intercepts. So the endpoint here, okay, maybe let's do it less vivaciously. So this endpoint is minus 180 and 1, and then the next endpoint is down here, which is not minus 90, oh my heavens, 90 and negative 1. And then we were asked to label the y-intercept as well, so that will be 0 and 1. Okay, so that's it for our y is equal to cos 2x. And I must also just label my graph. So this is the graph G. Then for our orange guy, we said that this endpoint is minus 180 and a half, and this endpoint is 90 and root 3 over 2, and then the y-intercept was 0 and a half. Okay, and that's all we were asked to label, so you know, that's all that we will label. Good and well. And let's just sanity check here. Oh, how inaccurate my drawing is. But here's one point of intersection, minus 120. The next point of intersection at minus 80. And then the last point of intersection at 40. So not bad, not bad. I'm slightly, moderately impressed. It's like rain on a something day. It's a free ride. Sorry, I'm doing other things. I'm doing other things. I will be with you shortly. Just humor yourself with something. Okay, I am back. Right. The last question here asks us to use the graph to determine the values of x in the interval that we've drawn the graphs for which f of x divided by g of x is greater than 0. Right, so f of x over g of x is positive, in other words. So we are looking at places where f of x, whoa, very, very delicate pen, that one. Either f of x is greater than 0 and g of x is greater than 0, or, I'll do this in a different color, f of x is negative and g of x is also negative. Right, and what I always find easiest with these questions is to, so let's say if we're looking at this first case, looking for places where f of x is positive and g of x is positive, I'll start by highlighting the places where f of x, for example, is positive. So that would be over here. Oh, that's not f. F is the orange guy. You see, this is why we need to label our graphs. Right, so looking for where it is positive, so that would be this piece, and then it is negative for a while, and then it becomes positive again over here. Right, so now within this subinterval and this subinterval, I want to see where is g of x also positive, right? So I'm looking, so maybe actually it's easier to highlighted this way. So we're looking from this x to that x, and then again from 30. Guys, the technology is being treacherous, right? Like that. Okay, so we're looking when x is between these two, we know that f is positive, and when x is between 30 and 90, we know that f is positive again. So then we're looking within this same interval between minus 180 and minus 150, where is g also positive? And we can see that it's positive also throughout that whole interval between minus 180 and minus 150. So that's good. That is an example of an area that passes, right? When x is between negative 180 and negative 150. And I'm not going to commit to brackets just yet, because those we always need to be careful about. But we can see that, yeah, when x is between these two, both f and g are positive. I'll come back to the brackets just now. Then let's look here, between 30 and 90. Between 30 and 90, fine, my f is positive. My g is only positive from 30, and then over here at 45, it dips into the negatives. So it's only actually between 30 and 45 that f and g are positive. So it's only between 30 and 45 that both of these conditions will be true. Right, so then that is the one side. So let's then think about whether we are including these boundaries, including one of them, not including any of them, blah, blah. So when x is equal to minus 180, both of these are above 0. So if I divide the one with the other, I'm going to get something positive, i.e. something greater than 0. So I can include minus 180. However, when x is equal to minus 150, as much as this is a positive value, the value for g, the value for f is 0. So I'm going to end up with 0 divided by whatever this number is, which is going to just give me 0. And we are looking for quotients that are bigger than 0, not equal to 0. So minus 150, sorry, you do not make the chop. So we exclude minus 150. Okay, let's think about 30. So with 30, when x is equal to 30, the value of the function f is 0, right? It's on the x-axis. So the y coordinate here is 0. The y coordinate here for g is something bigger than 0. So the division would end up being 0 divided by some number bigger than 0, which would equal 0. So then this quotient would not be greater than 0. It would be equal to 0. So 30, for a similar reason to minus 150, also does not qualify. Then 45, okay, here we have f being something positive, right? The value of the function when x is 45 is somewhere here, whereas the value of g is 0. So then we would have some positive number divided by 0. Division by 0 is undefined. So then that does not qualify. So 45 does not make the cut. So then in terms of f of x over g of x giving us something positive, in the case where both f and g are positive, these are the x values that will satisfy that. Right? So let's try this with the other case where we're looking for places where f and g are both negative. Right? Yes, okay, good. So we are looking for places where f of x is negative and g of x is also negative. So again, I'm going to highlight where f is negative, and that is this whole stretch over here. So from x is negative 150 up until x is 30, we just get negative values from the function f. So let me highlight that like this. And if you're not using coloring pencils in your maths exam, what are you doing? Like, how are you surviving, guys? How are you surviving? Please, we need those brain powers. I used to love taking those roll-up crayons to my exam because you can also erase them if you use them like faintly. Anyway, so this is the interval where f gives us negative values, and we're looking for places in that same interval where g is also producing negative values. So that would be over here we get negative values, right? So here it's positive, here it's negative values, and then for the rest of the time it's positive values. So it's only going to be in this interval that both f and g are giving us negative values, and therefore this quotient would be positive. So what is that interval exactly? That is when x is between negative 135 and up to negative 45, right? So negative 135, it goes into the negative values, and then negative 45 is where it stops with its negative values and produces positive values from there. And all this time f has just been producing negative values as well, right? So then again, our analysis of whether to include or exclude the boundaries. So we see that for both of them, g is equal to 0. When x is negative 135, g is 0, and when x is negative 45, g is again 0, meaning that this division would be undefined for both of these values, so we cannot include them, right? And so those would be our answers. Okay, it would be when x is between negative 180 and negative 150, between negative 135 and negative 45, and again between 30 and 45. That is where, those are the only places in this whole interval where this quotient would give us something positive. Right, let's quickly have a look at our answers and see. Hopefully we have not truly gone off course. First guy, we took the same approach, we arrived at the same answers. Second guy, our endpoints are the same, our y-intercepts are the same. Yep, all looks good. And then finally, why are we excluding all of them? Yeah, the memo excludes this boundary, but it shouldn't, because as we can see, f divided by g, when x is equal to minus 180, that will be a half divided by 1, which is greater than 0. So it is wrong of them to exclude this boundary, but yeah, all the other ones would have to be excluded for the reasons that we discussed. And that is that on that. They do write this in the nice fancy way, which I also would recommend. So you would say that x is an element of minus 180 to minus 150 union minus 135 to minus 45. Oh, I'm using the wrong brackets. Okay, union 30 up until 45. So that would be the nice proper way to write your answer. But of course you could write it this way, x is an element of this, or x is an element of this, or x is an element of that. That's also a valid way to write your solution. Right, thank you for joining the chat, and see you again another time.